Hello everyone, I am Sukirti. I am an educator, guiding, helping and motivating students from last so many years. Welcome to my channel, Learn, Practice, Achieve. Today we will discuss real numbers exercise 1.4 with number of tricks. So let's start. Now we will start with question number 1. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating repeating decimal expansion. So without doing the actual long division, so how to find out the answer for this question? So there are two important rules. First of all, we will discuss those rules, then we will start the question. So first important rule is, or important point is, if the denominator has only the factor of 2, 5 or both in the form of 2m into 5n, then it has a terminating decimal expansion. What does it mean? If we will take any number and if it has a digit, or if it has the prime factor 2 or 5 or both 2 and 5, then they are terminating decimals. Okay, so when we will do these questions, we will find out how it is coming. And the second point is, if the denominator has the factor other than 2 and 5, suppose in the denominator if 2 and 5 is there, as well as suppose 3, 7, 11 or any other numbers are there in the denominator, then they are non-terminating and repeating decimal expansion. So by using these two rules, we will solve question number 1. Now we will start with part 1, that is 13 upon 3125. 13 upon 3125. So when we will prime factorize this number 13 upon 3125, then 13 is a prime number, so we can't factorize this, and this can be written as 5 to the power 5. Okay, so here because the number is 5, so according to the rule we know that if the denominator is either 2, 5 or both 2 and 5, then they are terminating decimals. So this is a terminating decimal. Okay, in the same way, if we will do the second part, 17 upon 8, then 17 is a prime number, so write as it is, and 8 can be written as 2 to the power 3. Again the number is 2 here, so according to the rule, if it is 2, 5 or both 2 and 5, then they are terminating. So again it is a terminating decimal. Okay, third one, 64 upon 455. So 64 is a composite number. So 64 can be written in the form of either power of 2, okay, and 455 can be written as this. You can write as 2 to the power 6, and here 5 into 7 into 13. So because here the denominator in it is coming 5, 7 and 13, not 2 and 5 or 2 or 5, and 7 and 13 are the numbers other than 2 and 5. So it is non-terminating as well as repeating. Now if you will take 15 upon 1600, then 15 can be written in the form of 3 into 5. So no need to do the numerator. So write 15 as it is. Okay, and 16 can be written 2 to the power 4, and this 100, this can be written as 2 to the power 2 into 5 to the power 2. So here in the denominator you can see that the powers of 2 and powers of 5 are given. So again it is a terminating decimal. Okay, now 29 upon 343. So 29 upon 243, again 29 is a prime number and 343 is the cube of 7. Again here in the denominator neither 2 nor 5 is present, and the 7 is other than 2 and 5. So again it is a non-terminating and repeating decimal. Now part 6 of question number 1, that is 23 upon 2 to the power 3 and 5 to the power 2. So from this part, 23 upon 2 to the power 3 and 5 to the power 2, according to the rule, both are present in the denominator, that is the power of 2 as well as the power of 5. So it is a terminating decimal. In the second question, 129 upon 2 to the power 2, 5 to the power 7 and 7 to the power 5. If you will see this one, then here in the denominator, power of 2 is given, power of 5 is also given, but along with these two power of 7 is also given. Because power of 7 is included here in the denominator, so it is a non-terminating decimal as well as repeating. Now third, that is the 8th part, 6 upon 15. Now if this type of question is given, first check this numerator and denominator. Is there any common factor in the numerator and denominator? Yes, that is 2 3s are, 3 2s are and 3 5s are. So it is 2 upon 5. So again it is terminating. But if you will only check the denominator, you will find that it is a non-terminating digit, because 15 is, when you will prime factorization it, then you will get 3 and 5. Okay. So every time whenever you are solving this type of problem, check whether any common factor, first cancel it out, then find out whether it is terminating or non-terminating. Then here 35 upon 50, 9th part. Again some common factor is there. 5 7 ja, 5 10 ja. So 7 upon 10. Again, if we will factorize 10, then 7 upon 2 into 5. So here in the denominator 2 and 5 both are present. So that is why it is terminating. Then the last part, 10th part, 77 upon 210. Again, if you will see these two numbers, numerator and denominator, common factor is 7. So here it is 11 and here it is 7 3s are and 0. So 11 upon 30. Now prime factorize 30. So it is equal to 7 upon 2 into 3 into 5. Whereas 2 and 5 are present, but 3 is an extra number here, which is not required for a terminating decimal. So here this number is a non-terminating decimal as well as repeating decimal. Now I will tell you some tricks related to the terminating and non-terminating decimal. So if bigger numbers are given, how you will find out the terminating decimal or non-terminating repeating decimal? So if this type of number are given, first of all check whether these numbers are prime numbers or not in the numerator. Okay. So if we will check this number, then we will find out this can be written in the form of prime factorization, 7 into 7 into 3, and 1750 can be written as 2 into 5 into 5 into 5 into 7. So if this type of numbers are given, you can see in the numerator also 7 and denominator also 7. So cancel 7 and 7. So rest of the number, that is 21 upon 2 into 5 to the power 3. If in the denominator 2 and 5 or both 2 and 5 are present, then they are terminating decimal. Okay. Now come to the second part. 23 is a prime number, so you don't have to do anything. 4000, it is difficult to divide 23 with 4000. So what you will do, the simple trick is 4 into 1000. So if you will write in this way, then it can be written as 23, then 2 to the power 2 into 1000 can be written as 2 to the power 3 into 5 to the power 3. Because 2 into 5, 10, and if you will multiply 10 3 times, you will get 1000. So this is the easiest way. So here 23 divided by this number, 2 to the power 5 and 5 to the power 3. Again 2 and 5 are in the denominator. So it is also a terminating decimal. In this case, again check whether any common factor is present between the numerator and denominator. 209, if we will prime factorize, then we will get 11 into 19. And here again, because these are zero numbers, so we can write 11 into 10,000. Okay. Now 10,000, here 11 and 11 both are in the numerator and denominator, so you can cancel it. So the number left is 19 upon 10,000, and 10,000 can be written as 2 to the power 4 into 5 to the power 4. So again it is a terminating decimal. So use the simplest way or simplest trick to find out your answers quickly. अगर आपको मेरा ये आज का वीडियो अच्छा लगा तो सब्सक्राइब करना बिल्कुल भी नहीं भूलना, क्योंकि एवरी टाइम यू विल गेट न्यू एंड सिंपल ट्रिक्स टू सॉल्व ऑल द प्रॉब्लम्स रिलेटेड टू योर एक्सरसाइजेस. So please like, share and subscribe my channel, and don't forget to hit the bell icon to get my new upcoming videos. Thank you for watching.